Hey everyone and welcome back to the Java tutorial series. In the last video we learned about classes and objects. If you haven't seen that yet, check the link in the description below. As promised, in this video we'll take a deep look at methods in Java. We'll focus on how to define, call and understand methods step by step. We'll also explain what's special about the main method and how to write your own methods inside the class and how to call them on objects. Let's get started. First, let's create a package called methods and create a main class which is going to contain a main method. But wait, what exactly is the main method and what does its properties say? Well, the main method is the entry point of our application. It's a special type of method. Public is a visibility modifier and means that this method is accessible from the outside of a class. Static means that this method is not object-specific and can be called without the need of creating an object before. Void is the return type. Void means that this method doesn't return anything. It rather executes some code. Main is the name of the method, and string args are the arguments. To understand this all a bit better, we'll create our first own method, which is going to add two integers and return the result. Our method should be accessible from the outside of the class and therefore it's going to be public. I'm going to leave the static keyword out for the sake of demonstration, meaning this method cannot be called without an object. Our method is going to return an integer and therefore we type int after the visibility. I'm going to name this method add, and you can choose this name freely, but please stick to the camel casing convention. Int a and b are the parameters separated by commas. These are the inputs of the method. Our method is going to work with these inputs to process them in the body. The body, which is marked by the opening and closing curly parentheses, defines the logic of the method, and in this case we're just returning a plus b. Note that we didn't need the keyword void here because we returned a value. Now we can use this method by calling it with its name. But when we call it, there are several things we have to consider. Our method has parameters which we must give the specific values when we call it. So for our add method, we have to pass in specific values for a and b. Our method is also not static and therefore we need an object of the main class since we declared the add method in the main class. But creating an object inside its own class doesn't make sense, and therefore I'm going to declare this method static. And note that our method just returns an integer. It doesn't print the output, and therefore we need to wrap a print statement around the result. And then we get the expected output. So to sum up, think of a method like a reusable block of code. You define it once and then you can use or call it as many times as you need. Just like using a tool. Of course, adding two integers only takes one line and can be done without a method, but what if you repeat over 10 lines of code? A method in this case is very recommended, but not just for reusability, it is also to split the logic into different separate logic blocks. A method can do a calculation, print a message, return a result, or modify data. It is recommended that the method performs only one task. This principle is called single responsibility principle. Don't forget that. It is one of the 5 solid principles in object-oriented programming. But we can also use methods from other classes. Right-click on our package and choose a new Java class and name it calculator. Now let's define a simple method in this class, which is going to add two integers. This time we are going to declare it non-static, meaning there is no static keyword in the method declaration and we will need an object to call this method. Now to use this non-static method from the calculator class, we first need to create a calculator object and type the object's name and call on it the method. This makes sense in scenarios where the method operates on instance-specific data or state, meaning each calculator object can maintain its own separate values or configurations. But of course, in this case, this doesn't make that much sense because each calculator object should perform the same addition method. So if the behavior and output for all objects of the class is the same, this method could be declared static. We don't need an object to add two numbers. To call static methods, we type the class's name and then call the method on it instead of creating an object before. If we now try to add 10.5 with 10, we get an error because our just implemented method only supports two integer inputs but not decimal numbers. In Java, you can define multiple methods with the same name as long as they have different parameters or differ in another aspect in their declaration. But multiple methods with the same declaration inside one class are not allowed in Java. Creating the same method twice with the same name but differences, for example, in the parameter types, is called method overloading. So again, our problem is that our current method only supports integer types for input. And because if I call 10.5 and 10 to add on the current method, we get a red underline indicating an error since we pass in a double value but an int is expected. And therefore we need the method for double inputs. And in our calculator class, we can add the same method but with different types. Java will automatically choose the correct method depending on what type of data you give it. Remember in the last video when our person and car had methods which introduces them by printing their attributes? For this use case, we use the toString method. Normally, every class has a toString method without the need to declare it, because it is inherited from the object class. What inheritance is, we will see in the next videos. Just keep in mind that we use the toString methods following a specific declaration. So the toString method is exactly like our introducing method which we used in the last videos. It's a method that each class indirectly has and returns a string version of your object, printing, for example, the attributes. The toString method is a method which returns a string and has to follow specific declaration. It is a class which each class indirectly has and is inherited from the object class. So remember, each class inherits from an object class and each class indirectly has a toString method. But we will dive deeper into the inheritance topic in the next videos. In the next videos, we will also see how to override the toString method and return something meaningful, because if you don't override the method, this toString method, which is indirectly inherited, just prints the address of the object in the memory. But this ties into the topic of inheritance, which is coming up in the next videos. In the last video, I also showed that we can modify and set attributes for an object using the equal sign. However, this approach is not recommended because we want to access all attributes in a consistent and controlled way. Instead, it's best practice to use getters and setters. According to the unified access principle, we shall create each property as private, making it inaccessible from outside the class. To provide controlled access, we then create getters. These are simple methods that return the value of a private attribute we want to expose. And setters, which are methods that receive a new value as input and assign it to the corresponding attribute. This ensures better encapsulation and allows validation or logic during assignment, and keeps your code maintainable and flexible in the long term. So from now on, let's declare all attributes as private and make them accessible from outside the class using getters and setters. Instead of directly modifying an object's attribute from outside using the equal sign, we now call the corresponding setter method on the object and simply pass the new value as an argument. This doesn't change the behavior, but it makes the code much more readable and maintainable. The setter method is designed to take the new value as a parameter and assign it to the class attribute. For example, with this.age equals age, we update the internal age attribute of the object. It works similarly to a constructor, but instead of initializing, it reassigns a value. I hope now that this is clear, but that's it for today's video on methods in Java. You learned how to define a method, how to call it inside main, how to use methods on objects and how method overloading works, what the toString method is and what getters and setters are. In the next video, we'll dive into inheritance and you'll learn how to override methods like toString. A powerful tool in object-oriented programming. If you found this helpful, give it a like, subscribe and hit the bell icon to stay updated. Thanks for watching and see you in the next one.